is milestone number 5, Pythagorean theorem, angles and volume. Question 1. Did the side lengths of 9 centimeters, 12 centimeters, and 21 centimeters make a right triangle? Justify your answer. Because we have side lengths and a right triangle, we're going to use the Pythagorean theorem. A squared plus b squared equals c squared. We know that 21 needs to be c squared because it has to be the largest. So we're going to put 21 there. A and b can be either the 9 or the 12. 9 squared plus 12 squared. And now we have to solve and see if it gives the true statement. 9 squared, 9 times 9 is 81. Plus 12 squared, 12 times 12 is 144. 21 squared, 21 times 21 equals 441. Now we just have to add these two numbers together, and when you do, you get 225 equals 441. And we know that's not true. So we can put a slash and say that no, this is not a right triangle. Question 2. A right triangle has lengths of A equaling the square root of 11 meters and B equals 5 meters. What is the length of the hypotenuse? We know that the hypotenuse is C. So again, we're going to use A squared plus B squared equals C squared. The square root of 11 squared for A plus 5 squared for B, and C squared is what we're looking for. The square root of 11 squared cancel each other out, so we can bring down 11 plus 5 squared, 5 times 5 is 25, and that would equal C squared. Then we can add those two together. 11 plus 25, and that equals 36. So we have 36 equals C squared. And we're not looking for C squared, we're looking for C. So to solve C squared, we have to find the square root of both sides. And that cancels the 2 out. And the square root of 36 is 6. So C equals 6 meters. Question number 3. What is the area of the square off of the missing side? So we're looking for the area of this square. Not the side length, but the area off of it. We're still going to use the Pythagorean theorem. A squared plus B squared equals C squared. And I know this is C because it is across from the right angle. I'm going to use 4 for A, 3 for B, and we're looking for C squared. 4 times 4 is 16. 3 times 3 is 9 equals C squared. 16 plus 9 equals 25. So 25 equals C squared. We can actually stop there because we're looking for the square off of side C, which is going to be 25 meters. The length of side C would be 5, but we're not looking for that. We're looking for the square off of it, so we can stop at that point. So 25 meters squared would be your answer. Question 4. What is the length of the missing side? So this one's different, but I'm still going to find the right triangle, or the right angle, and find C. The 9 can be the A or the B. I will use it as A. So that means we're looking for B. So we have A squared plus B squared equals C squared again. 9 squared plus B squared equals 10 squared. 9 squared, 9 times 9 is 81, plus B squared equals 10 times 10, or 10 squared. squared is 100. I'm going to rewrite it over here so I have room to solve the equation. Because now I need to solve for b. So I'm going to have to subtract 81 from both sides to get b alone. I can bring down the b squared, and that's going to equal 19. I need to take the square root of both sides, which cancels those out. And b is going to be the square root of 19, or approximately 4.4 meters. Question 5. What is the length of the diagonal in the figure below? We have a formula for this one, and it is L squared plus W squared plus H squared equals the diagonal squared. So we have length, width, and height of the cube is going to equal the diagonal, which is right here, inside of the cube. So we have the length, the width, and the height. And it doesn't have to be accurate because we're given the measurements. So now we can substitute them into our formula. The L is 5, so 5 squared plus 12 squared plus 2 squared equals d squared. And we're going to continue to solve it. 5 times 5 is 25 plus 12 times 12 is 144 plus 2 times 2 is 4 equals d squared. Now we can add all of those numbers up, which is 173 equals d squared. So we're still looking for the diagonal, not the diagonal square, so we're going to have to take the square root of both sides. That's going to cancel out that, and we are left with the square root of 173, or approximately 13.2 for the diagonal. Question 6. What is the length of the hypotenuse? Here's our hypotenuse right here. And I'm going to go ahead and label it as C. So we have A and B, and we're going to use the Pythagorean theorem again. So A squared plus B squared equals C squared. I don't have numbers, but I can count. So A is going to be 1, 2, 3. 3 squared. B is going to be 1, 2, 3, 4. 4 squared. And we don't know C. We can't count C because it's on the diagonal. And it's not going to be whole numbers as we count up it. So we're going to solve for C squared first. So 3 squared is 9. 4 squared is 16. And bring down the C squared. Now we add 9 plus 16, and that is 25 equals C squared. We're not looking for the measurement of the square off of side C, we're looking for C. So we have to take the square root of both sides. That cancels, and we're left with 5 equals C. And that would be the measurement of your hypotenuse, 5 units. Question 7. What is the length of the line? Hint, create the vertical and horizontal lines that create the right triangle, which was done for us on the last figure. So I'm going to go ahead and do that. And I know this has to be side C because it is a hypotenuse, which is across from the right angle, also the longest side. And I'm going to name those A and B. So we're going to use A squared plus B squared equals C squared again. A is going to be 1, 2, 3, 4, 5, 6, 7 units. B is going to be 1, 2, 3 units. And we're still solving for C.
So now I can square each of the numbers. 7 squared is 49. 3 squared is 9. And bring down the c squared. 49 plus 9 is 58 equals c squared. We're not looking for c squared, we're looking for the c, the side thing. So we're going to have to take the square root of both sides. This cancels. We have the square root of 58, or approximately 7.6 units for c. Question 8. What is the measurement of angle QPR shown in the figure below? Well, let's find QPR. We have QPR. That means we're looking for the measurement of this angle. Because we know that the angles in a triangle all add up to 180, we can set up an equation. We have the 35 degrees plus 95 degrees plus x, because that's what we're looking for. And that all has to add up to a sum of 180 degrees. So we're going to add together the 35 plus the 95, and that equals 130, and then we bring down the rest of the equation. Now we have a one-step equation. We have to subtract 130 from both sides. That cancels out. So we have x equals 50. So the measurement of that angle is going to be 50 degrees. Question 9. What is the measurement of angle TUS shown in the figure below? So let's find angle TUS. We have T, U, and S. So we're looking for this angle. And we know that all of the angles have to add up to 180 degrees. But also we know that these two angles are supplementary. So if they're supplementary, they add up to 180. If this is 110, I could subtract that from 180 to determine the other angle measurement, and that's going to be 70. So I know this one is 70 degrees. So now I have one missing part of the triangle left, and I can set up my equation. 80 plus 70 plus x equals 180 degrees. And we can add those together. 150 plus x equals 180 degrees. We have a two-step equation. A one-step equation. Subtract 150 from both sides. That cancels, and we have x equals 30. So that angle measurement would be 30 degrees. Question number 10. What is the value of x shown in the figure below? So now we have some expressions to use, but we're going to do the same thing. Because we know that this angle plus this angle is going to equal this angle, we can set up a multi-step equation. So I'm going to say -1 plus 8x plus 46 equals 18x plus 5. So I'm going to look to see if I can combine like terms, and I do notice that I can combine the -1 and the positive 46. And if you made a T-chart, you would see that that would equal positive 45. Bring down this plus 8x and the rest of the equation. Now we need to start moving things to get the x's on one side and the regular numbers on another side. I'm going to move the 45 to the other side. Minus 45, minus 45. And I have 8x equals 18x. And positive 5 minus 45 is going to be negative 40. can move the 18x to the other side. So to do that, I have to subtract it from this side, which means I have to subtract it from this side as well. 8x minus 18x is negative 10x. And that equals, bring this down, negative 40. I can divide both sides by negative 10. And I have x equals positive 4. So all I'm looking for is the x value. So I know that the x value is going to equal 4. Question 11. Are the triangles similar? For triangles to be similar, that means they have the exact same size, the exact same shape, but the sizes are different, but they are proportionate to one another. But the angle measurements have to be exactly the same. So let's look at the angle measurements we are missing. For this first one, we have 80, 50, and we need to know this angle measurement. We know it has to add up to 180, so we can set up our equation. 80 plus 50 plus x equals 180. So 130 plus x equals 180. Subtract 130 from both sides. And so x equals 50. So I know this angle is 50 degrees. Let's look at the other one. The other one, we have 50 and 70, and we need to know this measurement. So again, set up your equation. 50 plus 70 plus x equals 180. We can add those together. 120 plus x equals 180. We can solve our one-step equation. Subtract 120 from both sides. So x is going to equal 60, which means this angle measurement is 60 degrees. So now we can look at both of the triangles. We have two 50s, 50, 50, and an 80 on this one. And this one, we have 50, 60, and 70. So no, they are not similar. Because corresponding angles are not congruent. Question 12. What is the angle relationship between angle 1 and 3? So here's angle 1, and here's angle 3. We know that they are not congruent, so that means they're actually supplementary. They are right next to each other, so they are adjacent. So you can choose adjacent or supplementary to describe the angle of relationship. Number 13. What angle is alternate interior to angle 3? So let me get rid of those. And let's look at the ones for question 13. So we're looking at angle 3 again. And we're looking for alternate interior. Alternate interior. So alternate means on the other side. I'm going to jump over to the other side, but it's on the interior still. So I'm going to go down to angle 6. So angle 6 would be the alternate interior to angle 3. Number 14. If measurement of angle 2 is 5x plus 10, and measurement of angle 3 is 4x plus 12, what is the value of x? So let's look at those two relationships, or those two angles, to see what their relationship is. So we're looking at angle 2, and we're looking at angle 3. They are vertical angles, so they are congruent. So we could set these equal to each other and solve for x. So we have 5x plus 10, and that is going to equal 4x plus 12. Now I have a multi-step equation to solve. So I'm going to subtract 10 from both sides. And you have other options to do that. Other than that, 5x equals 4x plus 2. Subtract 4x, subtract 4x. And I'm going to come over here. We would have x equals 2, so that would be our final answer. X equals 2. Number 15. Angle 8 is congruent to which of the following angles? So let's look at angle 8. Here's angle 8. Now we need to know which ones are congruent to it. So let's look at angle 6 first. Here's angle 6. They are supplementary. They're right next to each other, so they are not congruent. They actually add up to 180 degrees. B, angle 5. There's angle 5. They are vertical, so they would be. I'm going to put a check over part B, choice B. Choice C, angle 2. They are same side exterior, so they would not be congruent. They are supplementary. You also notice that this angle is obtuse and this one is acute. Choice D, angle 3. Again, we have a large angle, an obtuse angle, and a small acute angle, so those would not be congruent either. So choice B is our answer. Number 16. What is the angle relationship between angle 4 and angle 6? So let's look at those two angles. Angle 4 is right here, and angle 6 is right here. So I'm going to go ahead and notice that they're on the same side. And I'm going to notice also that one is acute and one is obtuse. So that means that they're not going to be congruent. If you look at them, they're going to be supplementary, so they would be same side and they're on the interior. So same side interior angles. Question 17. If the measurement of angle 6 is 25 degrees, what is the measurement of angle 1? So let's first look at their relationship to see if they're going to be congruent or supplementary. So we are looking at angle 6, and we're saying that it is 25 degrees. And then we're looking at angle 1 to see what its measurement will be. So angle 6 is an acute angle. It's small. And angle 1 is obtuse, which means that they're going to be not congruent, but supplementary. So they're going to add up to 180 degrees. So if the measurement of angle 6 is 25, we're looking for angle 1. They have to add up to 180 degrees. And we have a one-step equation. Subtract 25 from both sides. So the value of x, or the measurement of angle 1, is going to equal 155 degrees. Now let's look at the volume section. Question 18. What is the exact volume of this cylinder? First, we need to know the formula. So look at your formula sheet. And volume for a cylinder is V equals pi r squared h. And if you're looking at your image, we know that this is the radius, and this would be the height. So we can substitute those into our formula. R is 20, so 20 squared plus H, which is 25. We're going to keep solving it, so we're going to do the multiplication by squaring this first. So V equals 20 squared, which would be 4,000. Times 25. And you probably caught on that I messed that up. That is not 4,000. So let's start over with that one. V equals pi times 400 times 25. So if you multiply 400, and you multiply 400 times 25, you get 10,000. And we're looking for the exact, which means we're going to have the pi in our answer, because pi is not an exact number, so we need to keep it as pi. So the V, the volume for this cylinder, is 10,000 pi centimeters cubed, because this is a three-dimensional figure. Question 19. What is the approximate volume of this cone? So the approximate means that we're going to be estimating our answer. So we may have to round. Or we will have to round. Let's look at what we're given. We have the radius and the height. And now we need the formula. So look at your volume formula sheet. So volume of a cone is V equals 1/3 pi r squared h. Now we can substitute our numbers in. V equals 1/3 pi. R is 8, so 8 squared times, and the h is 12. So now we can do the multiplication, starting with the squaring and then multiplying it by 12. So V equals 1/3 pi times 64 times 12. We're going to continue to do the multiplication. So V equals 1/3 pi times 768. We're not finished yet because we need to multiply with everything and divide by 3. So we're going to have V equals approximately 804 inches cubed. After you multiply 7.6 times 3.14, or the pi button on your calculator, and then divide by 3. Question 20. A ball shaped like a sphere has a radius of 15 inches. Which is the closest to the amount of air needed to fill the ball? So we're looking for the volume of a sphere, and we need to start out by writing the formula. So we have V equals 4/3 pi r cubed. And we see that the radius is 15, so we can substitute that in. 4/3 pi times 15 cubed. We'll start by cubing the 15. And when you do that, you get 4/3 pi times 3,375. Now we're going to multiply it by pi, multiply it by 4, and then divide it by 3. And when you do that, you get V equals 14,130 meters cubed. So our answer choice is going to be B. Oops, forgot that one. Question 21. Which is the closest to the volume of a bowling ball with a diameter of 21.8 centimeters? So first we need to acknowledge that we have the diameter, and our formula actually has the radius in it. So we're going to start by writing our formula again. 4/3 pi r cubed. And we're going to substitute the radius in. because all we have to do is take this number and divide it by 2 because the diameter is all the way across and the radius is only halfway. And when you do that, you get 10.9. Now we can solve. We're going to cube 10.9. And when we do that, we can bring everything down. And then all we have to do is multiply and divide to get the rest of the answer. So with this number still in your calculator, you should multiply it times pi, multiply that times 4, and divide it by 3. And when you have that, you will get an approximate answer of 5,421.9. And if you look at your answer choices, that would be choice C. Question 22. Mark is going to melt some ice cream and pour it into the mold shown below. What is the approximate volume of the cone? So we're looking at the cone, and we have our measurements. We're going to start by writing the formula again. V equals 1/3 pi r squared h. So we're given the diameter, which is all the way across. So that means the radius would be half of 6, which is 3. So let's substitute all of our numbers in. R is 3 times 8. And we're going to square and then multiply. This would be 9 times 8. So that's going to be 72. Now all you have to do is multiply 72 times pi and then divide it by 3. And we're looking for approximate, so that's why we had to multiply it by pi. And we would end up with 75.36 approximately centimeters cubed. Question 23. What is the exact volume of the hemisphere shown below? And I know hemisphere is half of a sphere, so that's going to be important when I start to solve my problem. So I'm going to start by solving for the sphere, because then I just have to divide that number in half. So we're going to write the formula for a sphere, 4/3 pi r cubed, and I have the radius is 24. So 4/3 pi times 24 cubed. When we cube 24, we're going to bring everything else down, and we're going to have 13,824. Because we're looking for the exact, we want to keep the pi in our answer. So we're going to multiply by 4 and divide by 3 to get our final answer. So V, the volume of this sphere, would be 18,432 pi. That's for the sphere. So we need to cut this in half. Our final answer would be 9,216 pi inches cubed. Question 24. The cylinder shown below has a volume of 300 pi cubic meters and a diameter of 10. What is the height? So now we're given some different information, but we're going to start again by writing down the formula. So for a cylinder, we have V equals pi r squared h. And we've been told that the volume is 300 pi and the diameter is 10, which is all the way across. So that means that the radius is half of that, which would be 5. So the volume is 300 pi. I'm going to put it in place of volume with V equals, bring down the pi, r is going to be 5, and we're looking for the height. Now we just have an equation to solve. I'm going to start by dividing both sides by pi, because I know they're going to cancel each other out. So 300 equals, and I'm going to multiply the 5 squared, 25h. Now I have a one-step equation. Divide both sides by 25. 300 divided by 25 is 12. So I know the height of this cylinder is 12 meters. Question 25. A cone has a volume of 50 pi meters cubed. The height of this cone is 6 meters. What is the length of the radius? So we're going to start with the formula again. 1/3 pi r squared h. And I've been given the volume and the height. So volume is 50 pi. Bring down the rest. The radius we do not know, but the height we do. So times 6. Again, I'm going to start by dividing both sides by pi. I'm going to come over here, so I have 50 equals 1/3 r squared times 6. I don't like that fraction, so I'm going to multiply both sides by 3 over 1, the reciprocal, to get rid of that. So 3 times 50 is 150 equals, so this is canceled out, bring down the r squared times 6. So now I'm going to divide by 6 because I'm looking for the radius. I don't want to get that by itself. Divide by 6 on both sides. When I divide by 6 on both sides, I get 25 equals r squared. But I'm not looking for r squared. I'm actually looking for r. So I'm going to rewrite the problem over here so I can solve it completely. I have to take the square root of both sides. We've done that before. This cancels, so I have r equals 5. So the radius of this cone is going to be 5 meters.